Hello folks, and welcome to this explainer video on electrical power. Now what we're going to do in this video is really quickly learn an equation for electrical power, and we're going to look at its various different forms and then look at an example question. If you're working in my class, please do take the time to pause, take notes, but also to try the questions as they go. It's much better if you have a go at them and then see the answer as they come through. So let's get to it. When we're calculating electrical power, we use two other electrical quantities to calculate the values. And these are, put very simply, the current and the potential difference. Now, you may have studied these before, may not. Okay, current is an expression of how fast the electric current is traveling, how fast those charges are moving through a circuit. And the potential difference is really a measure of the energy that each of those charges use or spend or dissipate as they move through. But don't worry about the definitions at this stage. Those are for a later date. Right now, we'll just assume that we know that current is given by the letter I and is measured in amps, and the potential difference, which is symbolized by the letter V, which is also measured in volts, which is also a V. So it's quite confusing sometimes in this case. We've got units, volts, which is the unit of potential difference, which also has the symbol V. So as the definition there sort of says, we take P and we multiply two quantities together, I and V, to get our value of the power. The power is the product of the current and the potential difference. If we had a circuit, what we would do is we would measure the current using something called an ammeter and the potential difference using something called a voltmeter, and we'd multiply those two things together and we'd get our electrical power. In other words, P equal to IV. If we want to then do the rearrangement for I, then we're looking at P divided by V. P is on the top of the triangle and V is on the bottom. And you could try this on your own before seeing the answer. We would go for V, which is V equal to P over I. So again, it's one of these equations where we've got three variables linked together through multiplication. And if you feel comfortable with the triangle, then use that to your advantage. I sometimes like to come up with mnemonics when I'm trying to remember the equations, and the one that I came up with for this one is power is vital. Okay, P standing obviously for power, I for the current, and V for the potential difference. And power is vital, just one way of remembering that. However, remember, generally, this is the kind of equation that would be given on a data booklet, so it's not something that you really need to memorize from the start. Okay, if you've taken some notes on that and you feel confident, let's move on to an example question. Okay, there's our triangle there. Okay, we're going to use this one to calculate the power of a 4-volt lamp when a current of 0.2 amps passes through it. Now, regardless of whether you're in my lessons or not, I suggest you pause at this point and you have a go at the question. Okay, let's have a look at the answer. Well, obviously P is equal to IV. Okay, we're told the current and the voltage, I, which is 0.2, and V, which is 4. Okay, and it gives us an answer of 0.8 watts. Okay, remember to keep track of those units there. We've got 3 named units, named after famous scientists, and watt is our unit of power. Okay, now you may be asked in an exam question, for example, to then use this value. And a lot of students find this hard. I think it's because we're linking up different sections of physics. You might be asked to calculate the energy passing through the same lamp in, say, a certain time, in this case, 40 seconds. Okay, we're going to do that to try and express our answer in joules. So again, have a think about how you might do this. Have a go, and when you're ready, press play and see if you've got the right answer. Okay. You may recall that energy is related to power by multiplying by time. So energy is equal to power times time. Well, we've just calculated the power. Notice this is not just for electrical power, it's for everything. Any kind of energy transfer. Well, we know the power, 0.8 is in green there. We know that it's 40 seconds. No need to change the units because we're working in seconds. And we simply multiply the two together to get 32 joules. Okay, so just be aware that sometimes you might be asked a question which might seem indirect. For example, in an exam, you might be asked simply that bottom question, calculate the energy passing through the lamp, and you're given the voltage, the potential difference and the current and the time, and asked to multiply them together. Okay, so just be aware that you might be able to work in stages. Sometimes you'll be asked to calculate power, but you can also use that to calculate an energy. All right, fantastic. That's all for now. Please let me know if there's anything that you have found unclear or if this has gone a bit too fast, and we can go from there. All the best.